So let's math today. Last section of chapter 2b. We're going to do the quadratic formula again. So we've already done the quadratic formula once, so it's really, that becomes no different. The only thing that's going to be different now is what's underneath the radical might be negative, but we dealt with those yesterday. So it's really just putting two parts together, the quadratic formula, and then if we've got that negative square root, making sure we pull that negative, make sure we pull that I out of there and simplify as much as we can. So just a reminder, there's the quadratic formula. You already have this in your notes from the other day, so you don't need to write it again. Part we didn't give a name to, that I should give a name to, this part right here, that part right there is actually called the discriminant. You noticed on the directions of your homework, it said find the discriminant, and we just kind of, on that day, we just kind of wanted to breeze by it. I wanted you to solve the whole thing using the quadratic formula. I just forgot to change the directions. But that's the discriminant. So if they ask you to find the discriminant, really all you have to do is that part of it. So you don't have to do any more of it. But we're more worried about the whole thing. So let's do some problems. So first one we're going to look at is we're going to look at p squared equals negative p minus 10. And we're going to solve this using the quadratic formula. So remember, step one when you're doing the quadratic formula is you need to put it in standard form. Standard form is ax squared plus bx plus c is equal to 0. Now, one thing with this that we didn't talk too much about the other day, because some of you are probably looking at this and saying, oh, I can do one step and I can move the p squared to the other side and have negative p squared minus 2p minus 10. Yeah, don't do that. Try to make your a value positive as much as you possibly can. It just makes life a little bit easier when you have it that way. So what we're going to do here then is I'm going to add 2p to both sides and add 10 to both sides. And again, most of you at this point should be recognizing that if I'm moving it to the other side of the equation, all I have to do is change the sign from what it was when I'm looking at it to the other one, and then you've got it in standard form. Okay, so there's our standard form. If we list the a value, the b value, and the c value, again, the a value is the value that's out in front of the squared piece of it. In this case, there's nothing there, so it's 1. The b value is what's out in front of the x value or the p value, so our b value is 2. And our c value then is the constant at the end, 10. So now we plug it into the formula. So x is equal to negative 2 plus or minus the square root of b squared, so 2 squared, minus 4 times my a value times my c value, which is 10, all divided by 2 times a. And again, we talked about this the other day, but notice how I put everything inside of parentheses that I substituted in. It's just a good practice to get into. Let's make sure our phones are put away, please, and our headphones are off of our ears. Off of your ears. So now we simplify. So that's negative 2 plus or minus. 2 squared is 4 minus 4 times 1 times 10, so that's minus 40 all over 2. Just keep simplifying. Negative 2 plus or minus the square root of 4 minus 40 is negative 36. That's okay. Divided by 2. Square root of negative 36. Square root of 30, so we talked about this yesterday. Square root of negative 36 is the same thing as the square root of 36 times the square root of negative 1. Square root of 36 is 6. Square root of negative 1 is I. So this becomes 6i divided by 2. Okay, now you're 90% right at this point. But if you notice, if you don't use the highlighter, use a pen instead. that can be reduced. That can be reduced to negative 1 plus or minus, and this can be reduced to 3i. So there's your solution, and you're done. A multiple choice test might say negative 1 plus 3i and negative 1 minus 3i. I mean, technically that's what it is, but leave it there. For our purposes, just leave it there. So we've got that I that's going to be thrown into the mix today that we've got to be able to deal with. That's the only difference from what we were doing the other day. And sometimes it's going to show up, sometimes it might not show up. Okay? So here's our second one. X squared plus 4 equals 2x. Why don't you go ahead and have you do part of it, put it in standard form, and then write the equation itself and then stop, and we'll simplify this one together. Okay, so the formula should have that ready to go. Formula you should have the negative of negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 4. All of that divided by 2 times 1. Any questions with writing the formula itself? Are we okay with that part of it? All right, now we'll just kind of solve it together. The negative of negative 2 is 2. Plus or minus the square root. Negative 2 squared is 4. 4 times 4 is 16. So 4 minus 16 is what that's going to be. 4 minus 16 is negative 12. And again, just plug that part into your calculator. Put negative 2 inside parentheses and square it. Minus 4, parentheses negative 1, parentheses 4. And it'll give you negative 12. All divided by 2. Okay, side note, we're going to deal with negative 12 kind of on the side. Negative 12 is 4 times 3, or 12 is 4 times 3. I know the square root of 4 is 2, so this becomes 2i radical 3. So now I've got 2 plus or minus 2i radical 3 all over 2. Notice there are 2's in all of them. So I can just go 1 plus or minus I radical 3. Now understand when you're reducing this. Okay, let me pause for a second. Are we okay with this one? Does this make sense? Okay. Now, it's a complete side note here. But say my end result was 2 plus or minus 6i over 3. Since that's not divisible by 3, you can't reduce that fraction, don't do anything. Could you reduce this fraction? Yes, that can be. But in order to do what we've been doing and how we've been doing it, everything has to be able to be reduced. Both this first fraction and the second fraction need to be able to be reduced. If both of them can't be reduced, just leave it. So I would leave this answer like this. Is there technically another way to write it? Yeah, you could write this as 2/3, plus or minus 2i, but don't do that. Okay? If you get something that can't be reduced, don't reduce it. And honestly, if you have trouble reducing things, just, try your best, but whatever. Okay? Last one we're going to do today, then we've got a little bit more we're going to talk about, and then we'll call it a day. So you're going to go ahead and do this one from beginning to end. See what you get. Hopefully we're done in 4 minutes. I am not going to give you 4 minutes. I'll give you like 2 for this. Does it look right? The purple one anyway?
Yeah.
I think that's right. Where did I get the 4? What? Oh, I lost my negative. Good call. Good catch. Thank you. I lost my negative. Good catch. Thank you. Right, so there it is. So the purple. Everybody okay with the purple? Now that I got the negative sitting in there? Now, how did I get to the light blue, or whatever color you would call that? 8, 6, and 10 are all divisible by 2. That's the only factor that they have in common. So I just divided each of them by 2 to reduce the fractions. Okay? Any questions with the quadratic formula with i's? It's not so bad. So, to kind of sum up the unit itself, the whole thing we've been doing for the last, week and a half, 2 weeks now, is solving quadratics. When you're solving quadratics, the quadratic formula always works. If all else fails, use the quadratic formula. It always works. When can you factor? If it's 3 terms, you can try to factor. It's not always going to work. And we use the X method for that. Factoring also works if you have 2 terms, whether it's a difference of squares or taking out a GCF. So if you had like an A and a B value, so an 3x squared plus 5x, okay, that you can take a GCF out of. It's 2 terms you can take a GCF out of. We talked about this on yesterday, or I don't know, one of the days, maybe yesterday, or I don't know. It was a day this week. Taking the square roots, using the square root method, that always works when you have two terms and there's no x term in there. We don't have that b value. So that's where we're at. The assessment for this, remember, is going to be on Tuesday. Monday is just going to be a review day. I'll have the review video sitting inside of there. I'll put that in there later today for Monday. I'll put the review in there already for Monday. But the test is going to be on Tuesday. Wednesday of next week is PCR day. Although we'll have regular schedule in here, it's going to be a catch-up day. So if you have missing work on Wednesday, you'll work on your missing work, or if you have missing assessments, you'll work on those missing assessments next Wednesday.